space, building capacity, and research opportunities. I would like to welcome everybody, all speakers, audience, delegates, for joining us. To begin with, I would like to invite on stage Mr. Saeed Peer Mohammad Shah Qadri, who is a CEO and co-founder of Agnikul. Moin is an aeronautical engineer and having an operation specialist with over 7 years of experience in engineering, management, manufacturing, and supply chain operations. I would like to request Mr. Qadri to please start the session by his welcome address. Mr. Qadri.
Thank you, everyone. Thank you for your kind words, sir. To all the space pioneers, learners, and enthusiasts over here, it's my absolute pleasure to kick off today's session on behalf of the Federation of Indian Chamber of Commerce, with today's session revolving around the idea of capacity building and research opportunities in space. But before we proceed, I'd like to take a moment to personally extend my greetings to a few in the audience. Dr. M. Rajivan, who is the former Secretary, Ministry of Earth Sciences, Mr. Nilesh Desai, Director, Space Application Center, ISRO, Mr. Sudhir Kumar, who is the Director for Capacity Building Program Office, ISRO, would be the moderator of today's panel. Mr. Azli Kamil Napia, Director General, Malaysian Space Agency, Mr. Christer Nilsson, Vice Director General and Director of Technology, Swedish National Space Agency, Colonel Louise Phillip, Assistant Director of Space Affairs, Chilean Air Force, Ms. Tanya Pomoza, Head of Slovenian Delegation to ESA. And last but certainly not least, Professor Andy Coronois, CEO and MD SmartS at CRZ Australia. I'm really humbled to be talking about capacity building while in the presence of the Capacity Director himself of ISRO, Mr. Sudhir Kumar. I hope my words do justice and to initiate the program. Space. We've always heard about this iconic set of words, to infinity and beyond. Space is the only frontier that extends itself in this manner. The rapid progress made in space technology has led to extraordinary accomplishments for the whole human race, from the moon landings to the technology that has allowed us to produce reusable launch vehicles. At the same time, these space missions have provided powerful iconic imagery for humanity, and photos like the blue marble have become universally recognized symbols for a planet and its extraordinary environment and finite resources. Through the years, space has often been identified as the new frontier, fueling the imagination of kids, adults, entrepreneurs, companies, even writers and directors alike, who have created visions of a future enabled by fantastic developments in space technologies. However, consistent with what history has shown us, it is the fact that after an initial phase of exploration of a new environment and consolidation of relevant technologies, what follows is an explosion of business to exploit the new opportunities by the new environment. This is where we are today. This is what we call it as the new space or the space 4.0. We are in a period that has seen a shift of paradigms with changes of motivations, actions, and indeed technologies. The democratization and marketization of space is evident in the growth of the entire space market. The prices that have been offered are so low that it has attracted a growing number of customers, starting from the space agencies to multinational giants, startups, universities, and even schools, which are already contributing to the growth of the space. To fuel capacity building, research and innovation is the key. As we all know, research and innovation is the backbone of any country, and it entails three critical aspects. It pushes the frontiers of theoretical and applied knowledge. Many fields could develop further in the past decades through access to data collected from space and through access to research infrastructures for experimentation in conditions that only space laboratories can offer. Preparing space missions imply a whole exercise of innovation, where each tiny gain in mass or power consumption makes a big difference. Secondly, it enables a fusion of science and technology, including weather and climate sciences, biology, astronomy, cosmology, metrology, mechanical and power engineering, to name a few. Finally, the aerospace sector is the key for the future of our society and our economies too. I personally believe we could employ nearly 15% of the jobs in the next 10 years. Let me bolster these thoughts by conveying the need to reinforce our investments to support the research and innovation communities in their endeavors to move forward the frontiers of human knowledge, ensuring that all humanity can continue to use outer space for peaceful purposes and socio-economic benefit now and in the long term. This will one day happen through international cooperation, discussions, and agreements designed to ensure that the outer space is safe, sustainable, secure, and peaceful. With this thought, I'd like to invite Dr. M. Rajivan, who will be delivering the special address for today's session. Thank you for your attention.
Good morning and good afternoon to all of you. Dr. Nilesh Desai, Director, Space Application Center, Dr. Sudhir Kumar, Director, ISRO Headquarters, Dr. Syed Peer Kadri, Co-founder, Agnicol India, distinguished panelists and delegates. First of all, thank you very much, Vicky and ISRO, for inviting me to participate in this important session. After the launch of Sputnik in 1957, the progression of space technology has led to the development of hundreds of applications that use satellite data, including devices for everyday use, from satellite televisions to satellite navigation in our cars. On the other hand, it has made significant scientific progress in Earth, atmospheric and climate sciences, as well as in astronomy and astrophysics. Some of the highest public profile contributions from satellite applications are the extent of ozone layer depletion in the atmosphere, sea ice melting over the Arctic, signatures of global warming, and the existence of exoplanets and black holes. Other significant scientific achievements have been the Hubble Space Telescope launched in 1990 is one of the most successful advances in space exploration. The Kepler Space Telescope, which was built to find planets outside our solar system that are similar to Earth. And the Spirit and Opportunity were the two successful Mars rovers that helped us with many discoveries on Mars. Space technology also helped us to improve weather and climate forecasts and warnings, especially for tropical cyclone, flash floods, etc. Although the spectacular progress in space technology has slowed down a little bit toward the end of the past century, very important achievements like the development of the International Space Station and the robotic exploration of other planets and celestial bodies were continued. Space-based applications and services over the years have grown in multitude than originally envisaged. Many new applications are being developed worldwide to meet the growing user demands and requirements. The new services include application of space data for precision navigation, agriculture, earth environment monitoring, and more futuristic opportunities such as space tourism or asteroid mining. There are new trends in Earth observation, satellite communication, space exploration, navigation, and access to space. However, I shall confine only to the Earth observations and will speak very briefly. Climate change is a significant threat to our environment with the potential disaster consequences, and is an area where satellite technologies can help in tackling the challenge. A better understanding of climate change and its impact is necessary for governments and decision makers to define and implement appropriate mitigation and adaptation policies, including investment policies for large infrastructure with long life cycles. The related requirements for observations of essential climate variables, so-called ECV, are established and maintained by the Global Climate Observing System Program of World Meteorological Organization. Monitoring climate with more than 30 years of consistent data, meteorological satellites are an invaluable asset for climate monitoring and understanding our changing climate, and their role will grow increasingly important with the next generation of systems. However, exploiting this potential requires dedicated international efforts for recalibrating and reprocessing data, extracting climate records, and making them available to downstream applications and scientists. Both institutional and private Earth observation markets demand very high resolution and coverage, as well as short revisit time, with the aim to achieve real-time Earth observations. From surveillance to disaster monitoring and management of resources, there are literally hundreds of applications, but still there is a relatively low market adoption. This becomes obvious if we compare satellite Earth observation with satellite telecommunication. As in the latter sector, there is an abundance of purely commercial application organizations that operate without institutional support and in a user-driven market, whereas the EO market is still mostly often enabled by institutional budgets. There's a clear trend toward a more commercial EO sector that is facilitated by smaller sized and cheaper satellites, and several companies offering cost-effective solutions promising technically acceptable performance at a price than the market can bear. However, there is a very high competition in a market that still has too small a number of customers. The EO market has been growing over the last year thanks to a global growing interest from institutional and commercial players in buying EO satellites. A democratization of the use of satellite data leading to an increase in demand from end users. There is also strong pressure on EO data prices and push for diversification. Access to low cloud storage and computing and an increasing volume of satellite imagery at low cost is allowing the emergence of new type of EO market based on big data analytics and services, unlocking new business cases for the next decade. The changing and growing competition and the impacts of digital trends on EO data distribution business models are reshuffling the EO supply chain. Some of the key trends in Earth observations are the exponential growth in number of satellites. That means more satellites means more data. Cost effectiveness of small satellites means cheaper to manufacture and launch. Reduction in revisit time, which is very important. Sensor advancement, satellites can now image Earth at about 30 centimeters. Better space communication, which means faster data downloads. And more importantly, the rise of artificial intelligence, faster data processing and analytics. The Earth observing satellite constellation is a global asset providing widespread benefits across many applications and with various societal benefits, including the protection of life and property. Some of the issues, requirements of Earth observation satellite constellation are new and enhanced sensors for higher resolution and higher signal to noise ratio, new technologies like small sats or CubeSats, emergence of potential new payload hosting platform, commercial, new space platform, ride share, etc. New sensing technology. We need hyperspectral microwave, wind lidars, polarimetric RO, and reflectometry, etc. Increase in volume and diversity of data, advanced data analytics and using AI and ML methods, and spectrum challenges in the microwave region. One example is the spectrum which is used by 5G mobile. A risk due to space debris. For Earth observation, small satellites can be designed for a wide set of missions, keeping low design times, production costs, and deployment costs. One widely used type of small satellite is the CubeSat. World Meteorological Organization also recommends the use of CubeSat widely in their policy towards Earth system observations and Earth system modeling. I would like to highlight the need for a better advanced Earth observation data services. It is very important. The best example is the Copernicus being organized by European Union. It is the European Union's Earth observational program, looking at our planet and its environment to benefit all. It builds on a constellation of satellites that makes a huge number of daily observations, taking advantage of a global network of thousands of land, air, and marine-based sensors to create the most detailed pictures of the Earth. The technological prowess of Copernicus, especially in terms of availability and accessibility, has made Copernicus the largest space data provider in the world, currently delivering 12 terabytes of data per day. The various applications of the program are carbon dioxide monitoring, meteorological and climate science, pollution monitoring, agriculture, environment, and climate monitoring and water management, land monitoring, emergency management services, and forest management. We are in a period sometimes called Space 4.0 that has seen a shift of paradigms with changes of motivations, actors, and indeed technologies. Under the name New Space, there is an ongoing revolution in the space sector with the new players, commercial entrepreneurs, business entering in domain traditionally occupied institutional players to exploit the new opportunities. Successful entrepreneurs like Richard Branson and Elon Musk have entered the space arena, taking risks and challenging the established old space business model. I understand the Indian space economy is valued at US dollars 7 billion, which is around 2% of the global space economy. The Indian space sector needs to grow substantially over the next few years. With the significant market advantages like high demand for services, strong domestic manufacturing base, cost advantage, a large human resources pool, and ability to leverage IT skills, the time is ripe for the government to encourage a greater role for the private space industry in India. That was excellently done by the government of India very recently. In order to enhance the diffusion of space technology and boost space economy within the country, Department of Space India will now encourage the participation of private companies in space activities. ISRO, Indian Space Research Organization, shall complement Department of Space in its objective of opening up the space sector to private industries. In this regard, many reforms are proposed in the mode of execution of space activities in the country. For example, in order to enhance utilization and maximize benefits from the space assets, it is proposed to change the approach from supply-based model to demand-based model. A new Space India Limited has been established and it will act as the aggregator of user requirements and obtain commitments. And also they have set up, ISRO has set up, Department of Space has set up an Indian National Space Promotion and Authorization Center in space. It's an independent nodal agency for allowing space activities and usage of government-owned facilities by NGPs as well as to prioritize the launch manifest. We all should congratulate the Government of India and ISRO for these important and timely reforms which will strengthen the space industrial activities in India. With this great good hope, I will stop here. And once again, I thank you, Vicky, for giving me this opportunity. Thank you. Namaskar.
Thank you so much, Dr. Rajivan. Now, I would like to invite our guest of honor, Mr. Nilesh Desai, to join us on the stage and welcome give the address to audience. He's a director, Space Application Center, Indian Space Research Organization, ISRO. His fields of interest and research include data acquisition and digital signal processing for radar, navigation, and SATCOM signals, DSP and microprocessor architectures, to name a few. Presently, he is serving as a national president of ISRS Executive Council and vice president of ISSE. Sir, I would like to invite on the stage.
Good morning, all the participants, Dr. Rajivan, and all the other panelists of this very important session on space building capacity and research opportunities. And let me thank Vicky for giving us this opportunity to carry out this very important discussion related to building capacity and research opportunities. Now, as all of you, I'll keep it brief because I have a presentation. As all of you know, ISRO is the main protagonist as far as space activities in India is concerned. And our vision is harnessing space technology for national development. And for last many years now, we have also been pursuing space science research and interplanetary exploration. So that has been added in our major goals. Now, capacity building in ISRO aims at systematically carry forward the various capacity enhancement programs for the development of the country. And that includes not only related to infrastructure capacity building, but human resource development and providing opportunities for interface with academia as well as various industries. So today I will touch upon various activities in this regard related to capacity building and research opportunities which ISRO provides to not only its employees and other participants in the space endeavor of the country, but also to various academia and other industry participants, because that is very important in the coming era. And Dr. Rajivan sir has very rightly pointed out the requirements for the Earth observation and the new reforms which have been carried out in this country now since last 1 year, and how we take it forward. So in that domain, this importance of space reforms and its fallouts will become very important. So today I'll just try to bring out some of the aspects related to what ISRO has been doing in this direction, and especially with the example to my center, which is Space Application Center at Ahmedabad. So what activities we have been doing since long, almost 50 years, and how we plan to take it forward in this new space era. So I'll just switch over to my presentations. So next. So Space Application Center, as all of you know, is a center at Ahmedabad, located in the western part of the country in Gujarat. And incidentally, as all of you know, India is celebrating its 750th year of independence. And incidentally, our Space Application Center is also completing 50 years in 2022. Just please bear with us for a couple of seconds. So we have in Ahmedabad 3 major campuses here in Ahmedabad. One is located in the main, next. Yeah, so this is my place, Space Application Center. This is the main campus of Ahmedabad. Next. And these are the other campuses located at Ahmedabad, and we have one campus in Delhi also, which is mainly catering to the various earth station requirement of the country, and it also licensed with the various government department. And we have a very good Vikram Sarabhai Space Exhibition, which does the outreach as well as training programs for various students, both for schools and college going students. Next. Now coming to the various activities, as all of you know, ISRO has been it is under one umbrella. We have all the activities starting from launch vehicles to launch of the satellites, satellite development, and the related payload development and space applications. So at my center, in Space Application Center, we have payload and applications. And as you can see, the human resource strength of around 2100 out of 18,000 employees which we have all across the country are indulging in these various activities related to payload and applications. And as we can see the gamut of activities, including technology development and payload realization and the associated application, which will involve lot of activities related to data and signal processing, as well as the technology transfer and user interfaces related to all these aspects. And that adds to the overall capacity building, whether it is for human resources or for infrastructure. So I'll address one by one. Next. So as you can, all of you are familiar, we develop satellite communication, satellite navigation, as well as remote sensing, which involves radars as well as various optical camera payloads. Now if you see the cycle of development, so starting with design and realization over to the final application, which brings the benefits to the society and the common man, the activities involves lot of interfaces, whether with the academia, with industry, participation, and finally bringing it, solving the last mile problem, bringing the technology to the common man. And as far as remote sensing payloads and applications are concerned, one more step is added into that, is related to data processing, because the data which comes needs to be processed suitably, put into a proper format before it is being utilized by the common man. So to bring it to the application level, it also involves lot of processing and software development and its calibration and validation. So all these aspects are addressed with the capacity building and the human resource development, which we carry out at different centers of ISRO. Next. Next. So as you can see, we not only for the capacity building exercise, we have started with satellites for land and water resources, and moving on to urban mapping, high resolution satellites, to oceanographic satellites, and weather and climate related studies. So all these involves a lot of capacity building, and development of various space assets, which has been carried out under this program. And if you can see, we started with a 1 kilometer image development, and now we have moved on to a 1 feet type of images from a 500 to 600 kilometer orbit. So that involves lot of capacity building, both related to technology as well as overall human resources as well as the necessary intellectual development. Next. And same way as far as radars are concerned, microwave technologies are concerned, there also we have moved from a 100-meter resolution images to now a 1 feet type of images. So that also again resulted into a lot of infrastructure development, and especially because of the dual use technology which is involved as far as radars are concerned. So that involves lot of signal and image processing related activities as well as development of basic transmitter technology, which is going to be a very important technology as far as radars are concerned, because optical sensors are passive sensors. Unlike that, radars are active sensors. So that involves lot of infrastructure development and the other inputs which go into the processing and other related aspects. Next. Now coming to the capacity building framework which ISRO has organized, is that individual is at the center of all these developments, and organization provides the various infrastructure as well as budget and other resources, and followed by the operating environment and the policy framework. And as Dr. Rajivan has been discussing, now today till now all these operating environment and policy framework was limited to government sector, and now we are moving on to the new domain of new space era, where now all the infrastructure as well as the other capabilities of ISRO are being now made available to the industries as well. So industry need not develop their own infrastructure in a big way. They can utilize with synergy the facilities which are being offered or which are available at various ISRO centers. So that is the paradigm change in the operating environment and policy framework is concerned. Next. So this is how the skills of the individuals are harnessed by organizational strategies related to infrastructure and various facilities, and followed by operating environment where the, as I said, policy framework will drive the new era in space as far as India is concerned. Next. So apart from the capacity building, we also give lot of emphasis on various research activities where human and intellectual capital has its own predominance. So regarding that, I will touch upon some of the aspects where giving example at Space Application Center, how we have gone ahead with this development. Next. So this is how we try to involve academia and industry in developing the capacity building, not only in our places at the various centers of ISRO, but also in the other domains at various academic institutes as well as industry as well. Next. Next. So if you can see, as far as industry involvement is concerned, we have a participation mode with two types of activities, whether build to specification and build to print. So this is the normal model followed at all ISRO centers, where we specify the requirements and the industry build the various subsystem and components, and they bring back the systems to us where we integrate it and then do the complete integration, assembly, testing, and then launch the satellite. And same way build to print, where we leave it to the we give the technology or the various requirements in a more specified way to the industry, where they build as per our requirements and what the circuits which we have given, and then again bring back the modules to our places, and then we integrate and again do the same way. But now we are also moving ahead with a new concept called vendor complex, where we develop all the infrastructure facilities at our place, and followed by we invite the vendors to deploy their personnel. We also provide various facilities. So the intellectual hands come from the industry or the vendors, and they carry out all the activities under our supervision. So this is the third concept which is getting operationalized at different centers. It is yet to take a very concrete shape, but we have initiated steps in this regard. Next. So as far as industry is concerned, we carry out not only technology transfer, test facility requirements, consultancy, high rail training related activities, which are also supported at our places. Then various trade shows we organize and support activities of various organizations like FICCI, CIA, and other places. Then technology promotions and facility certification of individual industries, we also carry out tasks related to that. Next. And apart from MSME and other public sector units, we also now try to encourage under the new space reform policy how to involve private sector to carry out various activities. Now if you see a typical case in Space Application Center, so we have these various radar, SATCOM and SATNAV payloads, electro-optical cameras. So as you can see, radars have the maximum involvement of industries, and that is considered to be a very high niche technology area. So from there itself you can make your own judgment that how high-end technologies also can be transferred to the industries and various activities can be carried out. And as you can see, we major industry partners, almost you name any industry which is involved in these activities, and we have worked with them. So radars constitute the major load, and electro-optical cameras and satellite communication. Now satellite navigation is going to come in a big way as far as these activities are concerned. Next. So if you can see, out of the total procurement, we are trying to develop indigenization and promote Indian industries to the maximum level. So almost 55 to 60% of our activities, we try to promote Indian industries for various all these activities, and around 3,300 crore worth of contracts have been placed in last 5 years. This is the case only related to Space Application Center, one center only. Now you can imagine with the various requirements of different other centers of ISRO, how these numbers are going to be there operating in various aspects. Next. And as far as other ISRO missions, so not only from supplying raw material and components, but various mechanical and electronic subsystem, as well as fabrication, assembly and testing of various subsystems. So right now we are limited to that, but now we have, with some of our satellites, we have started that exercise with involvement of some industry in doing the integration, assembly and testing part also for satellites. So same way now we are going ahead with payload, because that being a very high technology niche area, because to achieve final specification. So right now the payload level integration and testing involvement is not very high as far as industry is concerned. We are trying to improve that factor also. And as far as build to print and build to spec, that ratio of 60-40, we are now trying to reverse that particular aspect also, so that the necessary expertise get developed in industry also, if we have to achieve the new space era related requirements. Next. So this is how the scenario is envisaged from 2010 to 2020. Although we have not progressed to the extent which we wanted, but still there is a good progress. But finally we want to achieve a 90-10 or 80-20 sort of ratio as far as the participation of industry is concerned in various space activity. And ISRO wants to concentrate more on the high technology, high technology related R&D requirements of the country, so that we embark on new missions. So basically we are trying to follow a NASA ESA type of model, where industry play a major role in the routine development of various communication, navigation, as well as remote sensing satellites. Next. And apart from that, as one of the important component is having technology transfers related to various technologies being developed. So there also we have achieved very good success. So a typical example of Space Application Center, where we have almost 143 MOUs with various industries, and almost 86 TT has taken place in last few years. So these numbers are going to increase only, and as you can see, it is encompassing all the areas of activities which are being carried out by ISRO. Next. And we have been working, as I said, with almost all the gamut of industries which are involved in aerospace related business as far as India is concerned. And of course, we have a lot of activities with other foreign manufacturers and industries are concerned, especially for components and sub-assemblies. We are dependent on some of the major commercial suppliers all across the world. Next. And now moving on to what Dr. Rajivan also mentioned, the space industry 4.0, where from doing and thinking for the systems, now we want to move to advanced automation activities, where industry 4.0 type of technologies get involved, and where systems that learn. So more and more involvement of AI, ML and other techniques are going to happen. Next. So these are the domain on which space industry 4 can concentrate, related to whether it is computing, cyber security, big data analytics, IoT, system integration, or additive manufacturing and smart system. So these are the various activities which we have embarked on. Lot of research activities are taking place, so I'll touch upon those activities also, whether related to 3D printing, space docking, and especially navigation and communication application put together. That is NavCom applications with the engagement of IoT devices. So that is also going to be a major exercise. And as far as data analytics is concerned, artificial intelligence is the domain where we are going to give more emphasis. Next. And as far as research is concerned, we have this, apart from having graduation and undergraduation level support for various students of engineering and science, we also support what we call in-house research, where technology development and advanced R&D, these are the major activities being carried out. And as I mentioned, in this new space era, we are going to now give more emphasis on this advanced technology and R&D related activities as far as ISRO is concerned, and leave the other technology development part. Once the technology is developed, we hand over the technology to various industries all across the country. So that is going to be the model on which we will be working. And in this regard, for academic development, we also have sponsored research program as well as space technology cells in various IITs and IISc and various National Institute of Technologies. So I will touch upon that. And apart from that, with various government departments, we have collaborative research and space technology incubation center to support activities of startups as well as students at the graduation and post-graduation levels. Next. So we have a very strong in-house technology development program and advanced R&D at all the ISRO centers. And as I said, now the emphasis in next 10 years is going to be more on this activity as far as ISRO centers are concerned, so that we move on to more and more advanced technology which can be taken up and inducted into our various missions. And the current missions, we would like to involve industry in a big way. Next. So this is a typical example of Space Application Center that we have around 178 technology developments, and which in couple of years it moved to almost 264 technologies. So these are the technologies which are available for technology transfer for various industries. Next. This is just a typical example. So similar cases exist in all ISRO centers. And as you can see, the various domains we have been working, so whether it is navigation, communication, or related to image and data processing, big data analytics, so antennas, SATCOM and SATNAV payloads. So all type of domains have been addressed, and in various levels we have achieved TRL 6 to TRL 9 sort of technology readiness levels. So technologies are ready. Now it is for the industry to take that giant step to grab these technologies and go ahead with the development for the newer programs. Next. And as far as for academia is concerned, as I said, we have a sponsored what we call sponsored research basket. Now earlier we used to leave it to the various centers to go ahead with their sponsored research. Instead of that, now we have centralized the whole thing, and Mr. Sudhir will tell you further about that, that we have what we call a response basket, where almost 250 such response proposals have been accumulated from all across the ISRO centers, and these are available for academia to give their proposal, and which will lead to the final not only R&D but final technology development. Same way we have incubation centers and regional National Institute of Technologies, which also have set up these academic centers, space innovation centers. ISRO chairs have been established at various important universities, and then we are sponsoring some of the Center for Excellence at different institutes. So once you give the proposal, we examine that and then work out the nitty-gritties related to that. And if you can see, almost all across the country, we are promoting various research proposals. So you don't have to come to ISRO centers. We will come to you people for doing the various activities related to space research. Next. So as you can see, we carry out various interest exploration meetings, various parts of the country, so that not only some of the regions in northeast and deep north region, they also get chance to participate in space related activities. Next. So these are the areas whether related to remote sensing, navigation, communication, science and technology, whether it is for the transportation, for ocean or water resources, for the moving vehicles, for timing related applications. So you name it, and all areas we have various technologies which are available, advanced R&D proposal which are ready to be exploited. Next. And we put lot of emphasis on human resource management programs. So we conduct not only various in-house trainings, but also organize various lecture series from eminent experts all across the country, as well as internationally renowned experts are invited to carry out workshops and training programs. And we also have a academic associate program with various universities in India as well as abroad. Next. And we, as I said, now emphasis is going to be more on advanced technologies and research areas. So especially say development of tubes, where only 2 or 3 manufacturers are there available worldwide who do the research. Similarly, for the Earth station development, for atomic clocks, which are the essential part of various navigation programs. So all these research activities have been taken up at ISRO, and they will be then transferred to industry for final incubation. Next. This is a typical example how we went ahead with this TWT, which is going to be a niche technology, whether it is communication, navigation or remote sensing requirements for radars. So that is one development which is with a lot of potential. Next. And apart from that, all of you know, under Prime Minister Science Technology Innovation Advisory Council, some 9 research areas have been identified, and ISRO has been concentrating on quantum frontiers and artificial intelligence, apart from working on the deep ocean exploration related technologies. Next. So artificial intelligence, next, and quantum frontiers. These are the areas on which we are concentrating, because these are going to be the technologies and processing requirements for future. Next. In fact, near future. And this is one typical experiment which we carried out for the first time in the country, where a 300-meter free space quantum communication link, because all of you know the importance of cyber security as well as our PIN code security of the lot of frauds have been happening as far as cyber activities are concerned. To overcome that, quantum communication is going to be the solution for that. And ISRO is going ahead with the development of space-based quantum communication satellites. So this is the first precursor to that. A exercise has been carried out at my center to do this communication link between 2 buildings 300-meter apart. And further it is now to be taken up to LEO orbits and finally to GEO orbits as well. Next. Next. Due to lack of time, we'll see the video afterwards. Next. Next. Can you move to next slide? Actually, there is a video for this experiment, but we'll skip it due to lack of time. So apart from quantum frontiers, we have been also working on, as I said, various artificial intelligence related activities for using the big data which we have accumulated from various Earth observation sensors, and lot of processing requirements have been taken care of by this AI ML techniques, where we do various 3D map generation for urban mapping as well as other exercise. So after that exercise which we carried out related to quantum frontiers, a lot of excitement is generated in the country, and we are further developing this technology to move on to the low Earth orbit satellite for quantum communication. Next. So this is how we have worked out this quantum communication related activities, building the 2 Earth station as well as 2 satellites in the orbit. So that is going to be a pilot project, and that will be followed by multiple satellites in the orbit. So to take care of the secured communication, where the all data transfer will happen through fiber optics and all communication links, but the encrypted code or the pin code of your transaction will go through the quantum communication. Next. Similar technology applies for radars also, where stealth technology, right now you cannot detect stealth targets. So that stealth target also can be detected by this quantum radar technology. So that is another area which ISRO is working on now. So as I said, now emphasis is more on doing such research projects, leaving out normal communication, navigation, other activities. Next. And this is how I was mentioning about the AI/ML techniques, because as we have accumulated a lot of data from various Earth observation satellites. Now this data is to be analyzed with big analytics and other various applications. So this is a typical model we carried out for Ahmedabad Municipal Corporation, where AI/ML based 3D city models have been developed with an error of around plus minus 3 meters. So this is a very good accuracy as far as 3D city models are concerned, and that is really a very promising area as far as data processing is concerned. Next. And we have 2 websites available where a lot of data analytics related research proposals and problems are available. Students and various startups as well as other technology domain industries can utilize this data, get in touch with our people, and work on these various activities related to Earth observation, polar science, atmospheric, glacier related studies, new and renewable energy sources. Next. And similarly in meteorology and oceanographic data archival center has been developed, so that gives you various information related to meteorology and ocean data which can be utilized for doing research in these related fields. Next. And for Gaganyaan, as all of you know, from technology centric domain, which is the ISRO's expertise, now we are moving on to a human centric approach. So that also brings in lot of new requirements where human rated technologies are going to be the order of the day. So that is another area in which safety critical activities are to be carried out by for various domains, whether it is related to astronauts or human beings or related to various technologies. Next. Whether it is launch vehicle technology. So to summarize, we have developed a lot of infrastructure facilities at various ISRO centers. So this is one typical example of space application center. We have, apart from clean room, EMI facility, high speed CNC machines, various specific tools for developing remote sensing as well as satellite communication and navigation payloads, large thermovac or compact antenna test and facilities. So all these are now available and getting open for industry to utilize these technologies and facilities. Next. So these are the specific facilities which are available for industry to utilize and do the development related to space. Next. And we, as I said, we have another campus where totally dedicated or infrastructure facilities, including a very large clean room, which mostly it is the largest in Asia. That sort of clean rooms are available at same time we can integrate and assemble almost 6 satellites at one go, big satellites, and small, around 20 small satellites can be integrated in this large clean room. So all these facilities are available. For the right middle, the picture of a vendor complex which has been developed as Space Application Center. Next. And apart from that, we do have various international space cooperation, so that also opens up lot many activities related to advanced space research. Next. And we have a very good training program related to satellite meteorology, communication and navigation, where Asia Pacific countries and scientists and researchers from these countries are being trained almost every alternate year, and we have participants from almost 15 member countries. And apart from that, we have smart entries, this training program in earth observation and meteorology and oceanography related research. And apart from that, we have very good exhibition and outreach program where we do not only virtual but we physically take all the models as well as various other activities of ISRO to the students as well as the researchers. Next. More information can be there from various literature which is available related to ISRO's various activities. Next. And as I said, we are now moving on to a new space era where it will open up all these activities for industry to take part. And all of you know this, so I don't have to emphasize. We are equal opportunity provider and highly motivated manpower now, and we want to inculcate same principle in academia and industry as well. Next. So we have been doing these activities for the man and society, and now taking it further for advanced research activities. As I said, our goal will be to concentrate more on technology and advanced research activities at ISRO various centers. Next. So thank you very much for your kind attention for this very important seminar, and we are keen to hear to various panelists from different countries further on this aspect. Thank you.
Thank you so much, Mr. Desai. Now, moving ahead, we will now start our panel discussion. I'm happy and delighted to tell you that today we have a wonderful panelists joining us from all across the globe. Some of them are here physically, and one of panelists is joining virtually also. So let me give you a small intro of all panelists. To start with, I would like to invite on stage Mr. Sudhir Kumar, Director, Capacity Building Program Office, Indian Space Research Organization, ISRO. He is going to moderate the session. Mr. Kumar assumed key roles in developing enterprise software solution for ISRO for handling procurement, stores, finance, accounts, and human resources. He is in charge of second vehicle assembly building project, largest rocket integration facility of ISRO. Thank you so much, sir, for joining us. Our next panelist is Mr. Azli Kamil Napier. He is a Director General, Malaysian Space Agency. He started his career as a senior geologist. Later on, he joined Malaysian Remote Sensing Agency, which is a government agency. He is experienced in spatial data and analysis and modeling activities, including satellite image processing. Thank you so much, sir, for joining us. He's joining us on virtual. Our next esteemed panelist is Mr. Christer Nielsen. He is a Vice Director General and Director of Technology, Swedish National Space Agency. Sir, please join us on stage. He is responsible for the overall coordination of the agency's technology development and in the areas of telecommunication, navigation, and launches. 2017 to 2020, Mr. Nielsen was chairman of ESA Industrial Policy Committee. Thank you so much, sir, for joining us. Now, I would like to welcome and call upon Colonel Louise Phillip to please join us on the stage. He has over 25 years of experience in logistic, strategic planning, and project management field, as well as in the IT defense sector. He was former Defense, Army, Navy, and Air Attaché to the Chilean Embassy in Italy, Poland, and Switzerland. Sir, I would like to call upon on stage. Please join us. Our next panelist is Ms. Tanja Parmozor. She is head of Slovenian delegation to ESA. Her portfolio includes the strategic direction of policy making in the area of internationalization, space, foreign direct investments, co-shaping of trade policy, within European Union and cooperation with international multilateral organizations. She was also a delegate of Ministry of Economic Development and Technology to ESA, Industrial Policy Committee, ESA International Relation Committee, ESA Administrative and Finance Committee, and a delegate to ESA Council. Ma'am, I would like to call upon you on stage. Our next panelist is Professor Andy Coronis, CEO and MD, SmartSet CRC, Australia. Andy has established 2 university research labs and a funded research center and was the research program leader for space integration, interoperability in the SEM CRC. He is a fellow of Australian Computer Society and a founding fellow of the International Institute of Engineering Asset Management, editor-in-chief of the International Journal of Information Quality. I would like to welcome Professor Andy Coronis. Now, I would also request Mr. Nilesh Desai, Director ISRO, to please join us on the stage, sir. I request Mr. Sudhir to kindly take over and start the panel session.
Thank you, Amar. Probably I think this would be the last panel discussion for this session at India Pavilion, probably celebrating the Space Week in the India Pavilion. We have a very good combination of panelists. Some are director generals and some policy makers, some technocrats, and some are administrators. I think this combination will give us a deep insights into the what is actually the ecosystem that is expected for building a sustainable, rather as a continuation of yesterday's or day for yesterday's discussion probably. How collaborations, how competitions, how the sharing will really help the space domain, world space domain. Probably to start with, I was supposed to be a speaker in this session, move to a moderator. Probably to do the justice, I just spent most of the things Dr. Desai covered. Probably some of the things I covered to set the discussion rolling. In ISRO, most likely I should say that these models should be an adaptive models rather than a regenerative or generative models. Because if the already wheel is invented elsewhere, why should we reinvent the wheel? That is one concept. The second thing is, one of the good models, especially Harvard Space Cluster, such kind of models will give us very good insights how the resources can be shared to optimize, on not only to optimize, to be competitive, and to make effective the use of the resources across the globe. The ISRO model, NASA model, it is very clear. The industry participation is more, government is more concentrating on the research activities, and government spending is more for the building the infrastructure and sharing the resources. And of course, India of late, it started into the similar lines, unlocking the space sector and space infrastructure to the private space industries. But this necessarily has to affect both upstream, midstream, and downstream. People enthusiastic and energetic startups, MSMEs, they are looking for entry into the space domain, because what we see, there is nothing like a different industry that exists exclusively for space domain. The industry which are doing conventional fabrication also can do the space manufacturing. The industry conventionally who can do the electronic components and subsystems can also play a role in the space domain. But only thing is, when it comes to the testing qualification program, probably the additional resources are required, which are very capital intensive. When industry or let's say any other agency wants to establish these facilities, the very important parameter would be the volumes. Definitely commensurating the investments, the volumes may not be what you call at par to get a good ROI, which is obviously a business strategy for any, let us say, corporate or industrial corporate. So in such cases, what kind of support the government agencies should extend to keep the space programs running within the country? What kind of collaborations that they exist, because ground systems, definitely satellites should go around the globe, and it's not possible to cover the entire globe from a location where the space agency is responsible. So for such kind of things, ground stations establishment is very crucial, especially for space science missions. Even some kind of floating terminals, floating tracking systems, tracking terminals are required amidst the sea throughout the trajectory path of the launch vehicle. So these are all some of the challenges in the capacity building. Probably I think I should say that this is the collaborations, international collaborations and cooperations are only the way for sustained space program across the globe. So keeping this context on for the discussion, panel discussion, I just wanted to request all the panelists to explain their perspective in two areas. One is how their space country or their space agency is working on these areas, what kind of collaborations they are expecting, what kind of possibility opening up their domain to the others, and where they can penetrate into others market or others agencies. Probably I think this is a very general and open discussion. Probably as the discussion go on, probably couple of questions and couple of clarifications can be start. To start with, I think Professor Andy is having some other appointment or some other engagement. Shall I request Professor Andy to speak out or to mention his perspective? Professor Andy?
Yes, thank you very much, and thank you for accommodating me with my next appointment. I appreciate that very much. Thank you for the privilege for me to present to you. I understand from your brief I have 7 or 8 minutes to make some introductory comments and then perhaps answer any questions that you or the other panelists or the audience wishes me to address to the best of my ability. I will just focus in 3 areas, if I may, in my 7 minutes or so. First of all, I'd like to just tell you a little bit about the journey and the R&D focus that Australia, but specifically my organization, is involved in. Outline some of the challenges as you have just outlined some of those as well, and perhaps also give you some insights about the capacity building and perhaps how might we progress in this area. First of all, the Australian journey into space only really began, and particularly new space, only really began in the last 5 years or so. We have been almost asleep until then in terms of making a big contribution into space service technologies and services. But we woke up about 5 years ago with great generous support of the Australian federal government with the establishment of our space agency, which is now around 3 years old. And we are really now very enthused. In fact, we are building so much momentum in terms of really embracing the opportunity of new space. We, just to give you an idea, that possibly 5, maybe 10 years ago, there would only be a handful of Australian space companies. Now they count into hundreds, albeit most of them are startup companies, but nonetheless, we have so many of our startups have really embraced this opportunity. But we're also moving into very much the new opportunities. The CubeSats are now moving into the small sats area, and we are building applications that help us. And in some areas, we are, I would think, doing pretty well, punching above our weight in some of those areas. In terms of academia, and that's where I came from before this role that I have, we are great believers of research-driven innovation. We believe that for the new companies to have a competitive advantage, they need to develop IP. They need to develop technologies that others do not have, so that they can not only meet the needs of the country, but also sell to the world. So we believe that research-driven innovation is critical in developing new technologies, developing new algorithms in a whole host of areas related to space. We also believe that in the area of collaboration, it is very difficult for one country or one company or one organization or even a group of organizations to do all of these things themselves. It is a high-tech endeavor, I don't have to tell you that. And therefore, collaboration, space is a global business, space is a global ecosystem, and we want to be a part of that. And this is why we came together here in Australia and we brought and launched what we call the Smart Sat. And Mr. Desai, I must congratulate him. I thought it was an excellent and very comprehensive presentation that he gave us. And a lot of the conversation was focusing on this opportunity that AI and the related technologies to AI are offering to space. SmartSat is a consortium of more than 130 organizations. It includes industry, Australian industry, but also international companies like Airbus and British Aerospace, Northrop Grumman, and so on, government agencies, and of course, our space agency is a great supporter of SmartSat, but also SmartSat has the strong support and commitment of the Department of Defense in Australia, as well as our civilian research organization called CSIRO. We raised $250 million in R&D, which is, for Australia, perhaps for the world, it's a small sum of money, but for Australia, it is actually the biggest industry research collaboration in Australia's history. And we're focusing very much in a number of areas, in a number of new areas, but particularly, and Mr. Desai mentioned many of those, novel communications. We feel that communications, satellite communications, are a critical element if we are going to be having ubiquitous coverage, connectivity around the world, both land masses and the sea. And of course, the new opportunities are around optical communications, or perhaps more precisely, the mixing of optical and RF communications, but also in the future, the quantum communications, quantum key distribution for security, and the new areas of communications, but also connectivity like IoT, universal IoT. Furthermore, a lot of the communication systems, like everything else, is virtualized, is becoming virtualized, and therefore in the communication systems, we are looking towards software-defined radio and cognitive radio to be the technologies of the future. As Mr. Desai mentioned, we also are involved ourselves in the new sensors for hyperspectral remote sensing, particularly for active remote sensing, not only passive, but looking at LiDAR, looking at microwave, synthetic aperture radar, and so on. And as I've mentioned, of course, AI and analytics are very, very important for us. So Australia also, because it is a big mining country, we have a lot of capability in remote operations, in communications for remote automation and autonomous systems, because we have mines spread across Australia. As you know, Australia is a huge continent, mostly deserted, not very many people in some of those mines, but a lot of those mines are actually controlled remotely. And therefore, we have that capability that can be used in space. And indeed, we've taken some steps in that. In terms of challenges, we feel that, first of all, there are many technical challenges. There are new areas of opportunity. I think it's very important for us, and we are trying very hard to focus on the right technologies, because Australia is a very small economy compared to the world, and certainly in the area of R&D, we have very limited funding. So we want to be using that in the areas where we would be able to make the biggest contribution, not only for our own country, but also for the world as well. The other challenge is really geopolitical. At the moment, and in the past, space has been very much for civil applications. The treaties have been very much about non-military uses. But the world is moving very much towards weaponization of space. And therefore, that is a challenge for us because we believe strongly in collaboration. Although we understand that governments require to defend and secure the nations, we want to be able to also have collaborations in areas where we involve other global players. And we are very open in most of the work that we will be doing in that area. And of course, the commercial challenge. The commercial challenge is very big. I mentioned before that we have hundreds of space startups. I'm old enough, as you can see, to know a lot about the IT industry and the shakeout that came with the IT industry back in the 80s and 90s, and also later on in the 2000s, the shakeup that came with the dot-com. Many of those small companies that actually were starting and had great ambitions, they hit the valley of death in many cases. The valley of death, particularly for R&D as well, where TRL 4 to 7 is probably the hardest leap to take. So that's an area for us as a big challenge that we at SmartSat want to help our companies. And that is why we are not just an R&D organization. We are a partnership of not only the R&D community, the industry, the space industry, or space and spatial industry indeed, but also the end users, the farmers, the new high-tech agriculture, precision agriculture, and so on, to identify what they really need so that we can focus on that area. In terms of government support and government contribution, if you like, my view is, and our view is very much that the government needs to be an investor of first choice, an investor in building the ecosystem, because one company or even a group of companies cannot do it alone. They need the government support, not forever, but until they actually are able to walk, to actually be able to survive and to thrive. Also, the government needs to be a coordinator of the activity so that all of it, and from what I saw from the great presentation that Mr. Desai has given us, India has already solved that problem. To be able to have ISRO and other organizations that are coordinating this activity of the R&D as well as the space industry innovation area. Also a door opener with international opportunities. We have great relationships with India. Australia shares similar culture, have a great history, similar history and foundations. And we want to exploit that to actually build those collaborative relationships. We in the academic environment can do so much, but government can actually help very much for that. And of course, I think that government needs to be a customer as well for the technologies and the solutions that industry is providing. It ought to be government as a client, government as a purchaser of those, and being able to then support the local industry, not only to build the industry, but also to transform the other sectors of the economy, as Mr. Desai said before, because the space has a wide reach. It's an enabling sector. It really enables not only its own industry, but enables pretty much everything we do, from navigations, from electronic transfer of money, from agriculture, mining, smart cities, and so on. Just about every walk of life, every activity, business activity, is in some way touched by space. So we are in a very privileged position, but also in a very important position, and we need to really ensure that we make a contribution there. Thank you very much for the opportunity.
Thank you, Mr. Andy, Professor Andy. I'm sorry, I do not know whether how long you will continue because of your other engagements. Shall I take a quick question from you?
Yes,
see,
absolutely. Thank you.
you have mentioned that very important point. Many of the areas in the space, the government is the ultimate user. Yes, we do agree with you. And having said that, what kind of FDA policy you have to open the international community to come to Australia and establish their own systems? What kind of liberalized policies you have, or what you are thinking of, and what is the ways out?
We have, and of course, I cannot speak for the Australian government. Our consortium is a consortium of industry and academia and government agencies. But the Australian government is very welcoming. Actually, at the moment, doesn't seem that way because of COVID border closures. But the Australian government is very, very supportive of companies. In fact, in my 130 organizations, I have 2 or 3 Indian startup companies, space startup companies that have actually come to Australia to establish a startup or to expand the activity that they have been doing in India. And the government, both at the federal level, but also at the local jurisdictional, the state level, provides very tangible support, very liberal support, and indeed, we have been extremely well supported. They see space, the federal government, our federal government sees space as a high priority for the nation. And even now, in fact, post-COVID, they even emphasizing this even with a greater emphasis than before.
Thank you, Professor Andy. I think this message should be noted by many other nations, that the opening of the space sector, not only on the paper or on the speech, but in action, when it gets opened up, probably I think that is the real opening. Can I take, after taking this clue, can I go to Mr. Napier to put forth his perspective?
Thank you, Mr. Sanjay Kumar, also Mr. Nicholas Desai, distinguished panelists and distinguished delegates. I would like to thank the organizer for inviting me to this such an important forum. Even though we are in different locations, but the ability of advanced technology has successfully connected us at any time, anywhere. I believe most of us agree that COVID-19 pandemic has resulted a huge impact on our life. Almost every country in this world affected. Some country has reached a recovery status, but many are still doing it best to overcome the pandemic. On the other hand, we do agree that on top of these casualties, the demand on technology was tremendously increased in communication, navigation, or even remote sensing technology. The limitation on the physical movement, social distances, and etc., the technology seems offering a better solution for our daily life needs. To some extent, low-touch, high-tech approach or solution are highly demanded to support our daily operation. In this situation, an advanced space technology will potentially play a significant role, in particular, creating an innovative solution or a new emerging technology. Some advanced countries have started their spin-off technology initiative, such as robotic automation, laser communication, and others. With regard to this impact of this space technology to society, today we saw many countries has optimized to some extent a space-based application in many areas, including food security, disasters, natural resource monitoring, communication, and whatnot. In Malaysia, for instance, space-based application technology greatly used in downstream activities with aim to increase production, strengthening the social well-being aspect, and empower the government services and deliveries. Space forecasting, for instance, increased up to 50% yields based on utilization of space-based application. Paddy crop management, for instance, increase the monitoring coverage up to 100%. Disaster management, and few more, just to name a few. Nevertheless, when we are focusing on the creating an innovation solution or new spin-off of space-based technology, it will highlight a few important aspects that should be considered. One of them was an ability to mastery an inclusive space-based technology. I mean, the capacity and capabilities. The fast growing or an advancement of space-related technology has shown that the capabilities in deep space exploration, AI, and others are highly demanded. It is really needs a good sustainable approach or knowledge creation, preparing sufficient expertise and proper innovative mode for our next generation may contribute to an interesting solution. On top of that, an extensive international collaboration in space technology may offer substantial solution. As mentioned by Prof. Andy earlier on, the international collaboration, it seems to be at most. Another point is initiatives such as research, industry, scientific exchange may also be a better solution for this issue. Another challenge is the adoption of the space-based technology among the public at large. Not only due to the fast-growing or advancement of the technology itself, but sometimes the consistency of cost and services. It also includes the domestic or international regulatory framework. Better space technology management or regulation include public-private partnership initiative may offer a great solution. Anyway, in positive mode, sometimes a challenge can be a good enabler to innovate space technology and to promote research of the opportunity. Thank you for the opportunity. Thank you.
Thank you, Mr. Napier, for your nice perspective. Probably, I think we'll come back to you on a couple of questions when it comes after the first round is over. Shall I now request Tanya, what is your perspective?
Yes. Hello. Thank you. Thank you, Mr. Kumar. And I'm really honored to share this podium today here with such a distinguished guest from the space sector. And I thank you for the invitation. Being part of the space sector today is really, it feels good. Why? Because space economy, it's increasing its importance worldwide and also in Slovenia. And the space technologies and data obtained from space have already been used in the fight against pandemic and will also serve us in the future in the recovery process. Remote working, telemedicine, teleeducation, logistics, all this wouldn't be possible without space technologies. And therefore, we believe it is even more important to strengthen joint efforts to faster develop the space economy, which is indeed helpful in our everyday lives and also for the business. Today, I would like to share with you some thoughts about Slovenia, what we do and what are our future plans. Our priorities are green and digital development with the space technologies, with the support of space technologies. Then the increasing involvement of the small and medium-sized companies. the cooperation between industry and academia, and of course international cooperation. We are a small nation actually, with only 2 million of population, and every step we do in space, it's a huge achievement. And like I was listening to Andy, we also woke up 5 years ago when we joined ESA and in European Space Agency, and there we participate in 4 programs, and these programs were selected upon the request of our industry. And we are now very good in technology program, Earth observation, in human and robotic exploration program, and in scientific program. Our companies are in various fields of the space sector, such as 3D printing, new materials, control and measuring systems, microgravity facilities. In fact, just at the beginning of this month, we just transferred to Slovenia the so-called short-arm human centrifuge, where the bed rest studies will be carried on this centrifuge. So, and these studies will help astronauts in the space, and will help the general public on Earth within the medicine. We believe that the cooperation between industry and academia with governmental support is crucial to be successful in space. Why? Because space is everything. It's from the agriculture to artificial intelligence and all sectors in between. And we pay a special attention to Earth observation. Why? Because with data you can monitor climate change, pollution, then also the greenhouse gases emissions. So actually, with this data, we also help to our agriculture sector, environmental sector, and also other sectors as well. And we also pay special attention to small and medium-sized companies and to startups, which are being now really a good part of the space ecosystem, and also a good partner to traditional primes. And we believe that the traditional primes wouldn't be so successful without these small companies. In Slovenia, we mostly have small and medium-sized companies. Today's event, you managed to gather really all sizes of the countries, from small like we are to bigger ones. But when it comes to space, I believe the size doesn't matter. What matters is the innovation, new solutions, new ideas, and quality. And what we are trying to achieve in Slovenia is, if we cooperate, we will have a success. And without cooperation on the, let's say, country level or international level, we will not have success, especially not in the space sector. So I thank you again.
Well said. I think the space is only the area where there are no boundaries, both horizontal and vertically. Nice. I'll go to Colonel Louise Philippe. You see, now we see many of the countries, early entrants, let's say last 4 or 5 years, and on the other hand, the countries like USA, USSR, ESA, India, China, there are long-standing, they had a very long history in the space applications and self-reliant. And as I see, many of the countries, while showing the interest for establishing the ecosystem in satellite building and building the technologies for self-reliance, I think more they are relying upon the services to start with from the advanced countries. Advanced means not in the space, advanced countries, and slowly grow. Will you be with me, or what is your perspective? Would you have any difference of rather a thought process as far as Chile is concerned?
I agree with you, but probably if we compare the new space, like you tell to us, with the cheese play, we consider that the new space will provide to us the board. So we are a new player in this industry, a beginner one, but doesn't matter because you could be a master or a beginner like us, and also doesn't matter the kind of pieces that you have. You could have the very traditional one or sophisticated one, because at the end, as the space domain provides the board, everyone have the chance to allocate the pieces in a different way with a different strategy, and play with the new rules and with the new dimensions that the new space provide to us. So at the end, it could be possible to play as a beginner or as a master, and develop technology and create knowledge that for sure, as you tell to us during, particularly the professor, will provide to us a lot of tools and results, that will support for sure the national development, but not just the national, because I also agree with you. At the center is the human being. So that technologies, that knowledge for sure will push and will allow to us to be a better human being, have a good life in the earth, a better one, with the technology that we're able to build and develop for the space. So for that reason, our national space strategy is quite disruptive. Could be probably the regular one. Now we realize that the space industry is growing up, so we are moving the border. For example, I work here for the defense, so and also this panel is quite representative about the context of the space industry. Also here we have a singer, and he's part of our national space industry. He play with the songs of the space, and he mix it. So pay attention to him. He will be very well known. And this approach is a comprehensive approach. So we define a strategy. So strengthen our national space system, base of our national space program, because that program will provide to us the asset, the space asset, the capability. Second, the facilities. And third, the new space national governance. So we are working in parallel with that. And I think as a country and related with the space economy, the idea is to use the space industry as a resource, as a tool, to move our economy to the very commodity-based economy, to a digital one, to a space one. So with that in mind, we are focused first of all into develop technology. For that reason, our National Space Center will be an international one. So everyone could be the chance to come to Chile and develop technology with us as a team. The second point is the knowledge creation, because the knowledge is the base for the digital economy, is the input. And third, the talent promotion is so important. But not just at the research level. Now, last week, we start with our national school space program, because the talent promotion need to be allocated also in the classroom. And also the service provision. As a country, we have a very unique condition. Now, if you want to go to the space, you have the chance to go to Chile, because our natural condition is so similar in some place, like the space. So for the architecture development, for the engineering process, for example, you will have a lot of opportunity to test and to prove on the Earth the technology that you need for the space. So service provision related with the launch capability, with telecommunication, is one of the key points here. As a country, we have fiber optic for all the country. You know, the side of Chile is like to fly to Madrid to Dubai, and a little more. So it's so big distance. But we have all the connection with the fiber optic. And now we are arriving to Australia and New Zealand by our own fiber optic. And now with the laser communication, we will have the chance to build a bridge to the Atlantic. And hopefully we want to be the first country to connect Antarctic with the fiber optic. So the space industry give to us the chance to be a node, a digital gateway for the region. And hopefully have the Chile one of the international scientific pole for technology development and knowledge creation. So this is the strategy, and this is the reason why, as a defense, we are working in a very interagencial approach. And also why we consider our national space program as the base for the international collaboration. So that means we are looking for a multilateral space program, a binational space program as well. So thank you for the chance to be here. It's really a privilege.
Thank you. Very nice, nicely narrated the actual reality. Now I'll go to the last panelist, Mr. Nilsson. Probably I think Swedish is also very space enthusiastic, and you had a couple of interactions with ISRO and you are part of the several programs. Probably rather than while talking about the Swedish, I just want you to just dwell on one perspective. Let's say one side, the satellites bringing nuisance into the space, because in the terms of debris, and we are not matured for capturing them back. That is one thing. Second thing is capabilities are there for higher nations for putting the very high-end technologies and making the resources available. They are capable, I'm not telling. And at the same time, every nation wants to put their own satellites to have several reasons, maybe geopolitical, security, safety reasons. What would be your perspective, rather, because you are among them, probably you are more, what could be the right model where a platform can be made different, all the space fractions? I'm just imagining all space faring nations for the civilian applications, they will collaborate, and in that one, whoever have got capabilities, somebody have got capabilities of launch vehicle, somebody on navigation, somebody on remote sensing, somebody on it is a communication, somebody on small satellites, different applications. This is resource sharing basis. All people will contribute like United Nations. And how you see that kind of imaginative perspective? I just wanted to.
Thank you, Mr. Kumar. And first I would like to say that I'm delighted to be here among such a thriving mix of nationalities and cultures and intelligent and beautiful people, of course. And I will try to address your question now, and also one of the questions in the ingress of the panel, namely the one about building capacity. But I will do it from a slightly different angle. And first I will say a few words about Sweden. I hope you know we're a country far north in the northern part of Europe, a rather small country. Perhaps not from the square kilometer point of view. I did some research. We're only 7 times smaller than India when we're talking about square kilometers. On the other hand, you have 138 times our population. So we understand that we are a very, very scarcely populated country. But as Chile, we are also a very elongated country. And we have territory above the Arctic Circle. And that's actually where the cradle of the Swedish space adventure started already in the beginning of the 60s. So not 5 years ago, but we've been acting on space for quite a long time. And of course, this Nordic situation made it possible to I mean, we started with space physics. We're studying the Northern Light and the Aurora Borealis from our own rocket range up in the northern part of Sweden called S-Range. And space physics is actually still a stronghold of Swedish space science. But of course, the space landscapes of the 60s, I mean, today it's completely different. We've heard before that for a very long time, the space has been a governmental and analytical playground for institutional players and only a few ones, I would say. But if you look at today, space is accessible to everyone. And I mean, not only is space a very important piece in the puzzle of addressing global societal challenges, I mean, it's also providing, as we've heard, extremely valuable information to make effective agriculture and forestry. We are tracking vessels on the seas, but today, I mean, literally, everyone has space technologies at his hand, literally, and this is, of course, of the new space area, the commercialization of space, and this is a tremendous market, and we only see the beginning of it. And I guess that it's only the imagination that can stop you from what space can provide in matters of services and applications and so on for humans. So, but what are the challenges then? And I give you one here. Space should be accessible to everyone on equal terms and for peaceful purposes. So, over the last decade, the most attention in space has been given to what we call new space. It has also been addressed by some of my fellows here in the panel. I mean, new space, in my point of view, we are talking about entrepreneurs and private investors that are trying to challenge the old space monopoly of space. That's what they're doing. And it has been given a lot of attention over the last decades. But you have to remind yourself that the old space, I mean, they hasn't been laying on their backs either. I mean, they have provided over the last decades, for instance, Earth observation systems that can give you pictures in almost real time, globally, down to the precision of a centimeter. It's the same with the navigation systems, also global coverage. They can tell you where you are, also with the centimeters precision. And along with that, of course, the more traditional worldwide telecommunication systems provided by satellites. And if you take this amount of information and those services that they can provide and you put them together, if you control them, you have a very powerful mix. And if you have a power, you also would like to protect it. And we see today, in a slightly destabilized political situation in the world, many states are starting to group space with defense in a much tighter way than it has before. And I think that it was mentioned here that space has no boundaries. I was at another panel yesterday in the Swedish Pavilion on space and sustainability. We had a few astronauts from Brazil, from the UAE, and also the Swedish astronaut, Mr. Christer Fuglesang. And I don't remember whom of them who said it, but I said, when he first came to the International Space Station and he looked at the Earth, one thing that he realized was that he couldn't see any borders. From space, there are no borders are no borders on the Earth. And what we really have to make sure is that potential conflicts over borders here at Earth are not transferred up to space. And this means that I think one of the most important things that we have to do over the coming years is for all space agencies and space actors to really come together and adopt binding treaties and regulations in order to make sure that potential conflicts, I mean, that we really have no borders also in space. Uh, I was talking about this power that you have if you have the information. So one solution then, of course, to this to safeguard the space is to really see to it that we have those global corporations that you are talking about. Information from the space infrastructure should be open to everyone, free at charge. Because if everybody has the same type of information, there is no need for you to build your own systems to have the data integrity. And if you don't have to build your own systems, you will free up a lot of resources. And this is my point on the building of the capacity. I mean, we don't really need 5 or 6 global navigation systems, right? And it's the same with the Earth observation satellites. Europe has a system, US has a system, India has a lot of satellites, Asia, the Russians, everybody builds satellites. Also on the telecommunication side. But if we could cooperate around those ones and have common systems with equal access, a lot of resources would be freed, and a lot of capacity will also be freed in order to move space forward and the use of space for the best of humankind, I would say. Thank you.
I think this perspective, I think this panel sitting in the Dubai Expo, World Expo, I think should open new discussions and new probably avenues for such kind of cooperations. Pray God that should be in place. Especially if you say the localized applications like cartography and maybe some of the local applications, that's fine. If you take the food security, there is some abundance in elsewhere and there's a famine in another part of the world. Probably we are mapping this food security within the country. And if you just imagine globally, you'll be able to map. If excess production is there, ultimately they'll put into the storages. After a couple of years, they'll be wasted. Whose the source is nature? Nature is nobody's baby. So if such kind of imagination, if we say the food can cross the boundaries of the nations and go to area where they need, you just imagine that kind of culture, that kind of so facilities, how it would. I'll just seek advice of Neelaj sir. Sir, how this proposal could be, how you expect that, what could be the impediments if for implementing such kind of proposals when you wanted to cross the national boundaries, especially for the peaceful purposes and especially for the environmental, food and very essential needs.
Thank you, Mr. Sudhir. And let me congratulate all the 5 panelists for airing their views and putting it very succinctly in a very explicit manner. But I slightly differ from my Swedish friend here, because although frequency and borders and all the points which you touch upon, they are well received, but there are universal needs, there are regional specific needs, there are country specific needs. So considering all that, there is a scope for everybody to participate in the space endeavor. So in that sense, you gave example of navigation systems especially. But even to avoid monopolies, from that angle also you need multiple systems, multiple navigation system. And so I'll give you a typical example of Indian system, which is more regional specific. Our navigation system is only region specific, covering India and 1500 kilometers around that. So one can always start with their own regional or a country specific system and then advance into the global system. That is one aspect. And you rightly mentioned about there are no borders in space, but same way frequency usage wise, all of you may be aware that there are different group operating when at ITU level and all, because getting frequencies for specific application is really a very strategic way of handling those aspects. So from that angle also, all countries should participate into that. And especially now, it also opens up new vistas of research, as I was mentioning in my presentation. Okay, with the advent of say 5G and tomorrow 6G and 7G, which is in the offing. So considering that, it also opens up new vistas of research, advanced research, how we can live with the requirements of 5G. At the same time, space communication has its own frequency requirements. So to have a conciliatory approach, accommodating the requirements both for space telecommunication as well as terrestrial telecommunication involving 5G or 6G technology. So that also gives a lot of challenges as far as technology and research is concerned. So from that angle also, various aspects are to be addressed, and that opens up new vistas of development as far as advanced technologies are concerned. And further elaborating on the topic, I concentrated more on the space assets or the space segment. But as Mr. Sudhir was also mentioning, it is not only the question of space segment, but there is ground segment as well as user segment. There are two other associated segments also involved as far as space technologies are concerned. So it goes hands in hand, both the ground segment, user segment as well as space segment. So in that sense also it opens up lot many areas not only for academia and research but also for industry to participate in a big way in this space technology or space sector. So all in all, it's really a very important way of handling these space activities all across the world, that space is not only, as many of you pointed out, working in space, but it also involves lot many technologies involving ground segment as well as user segment. So in that sense also, this is a really challenging times we have, and we look forward to that. And especially coming to the space reforms which Indian sector is now going to envisage. So we have been always taking pride as far as ISRO or India is concerned, that we have everything under one umbrella. So that has been a unique USP of ISRO space program or India space program, that we have launch vehicles also, launching pad also, we have satellite development or technology also, and going into payload or sensor specific development as well as applications all combined under one umbrella. But that also dwarfs many of the developments of individual sectors are concerned. So in my opinion now, once we are opening up space sector, there is also a need to think differently in this particular aspect. So I will give you a typical example of our electricity boards in India, where there used to be again everything under one umbrella: generation of power, transmission of power, as well as distribution to the individual customers or the consumers. So it was totally coming out to be a loss-making unit only, all said and done, individual specific electricity boards. But the moment our government started dividing into three different sectors: generation of power as one sector, then transmission of power as another specific sector, and distribution to the consumers as third sector. Now all the three are making profit. So that also opens up a new direction as far as space research or space technologies are concerned. So if we can segregate into launch vehicles and launching of the satellites, or satellite development and associated technologies, payload development and application development, then that also will open up new avenues for not only research and technology development, but make it in totality not only a hostage to government funding or other initiatives, where because many of us or many countries depend on only government for the funding in the space sector. So that also limits its growth, because government, as our Australian friend was also pointing out, it has a limited resources to give to space sector, and many of you also may be facing same problem. But if we divide it this way, that may also open up new areas, especially for funding, and that will also give bring in more avenues for private sector to participate on these different sectors as well. So I thank all the panelists for very illuminating and very different perspective to the same problem all across the countries, and hand over to Sudhir for his.
Thank you, sir. Thank you. Thanks a lot. I think most of the speakers speak about the government participation, how actually initially that will shape the space sector. Then second, the industry participation to make it more open, because governments cannot be so open because especially in the international geopolitical reasons. I think one way government has to slowly withdraw and make the industries more enable, because industry has got a privilege to cuts across the boundaries. And of course there is a consensus that for localization with globalization, The local, to some extent, we have to do it because to secure our own priorities and globalize the space applications to have to be more competitive and to be more resourceful. I think this is this capacity building model probably to be discussed at length with other national space agencies also, to enable each and every partner in the ecosystem to contribute more. I think the panel discussion was quite fruitful, even though the time is running up. The final quick comments from each and every panelist I seek, maybe 1 minute. What his perspective could be, especially with respect to his national space agency or his country. I'll just go to Mr. Dapia. Just quick 1 minute summing up.
Thank you. So the Kumar, in Malaysia, we are starting up into the promoting the new approach in space technology development. I mean the public-private partnership. Under the new national space policy, 10 years implementation approach, so we are highly promote the establishment of the local expertise, or even the new startup, or even the industry. Even though we are previously more towards on the downstream activity, now the needs and the demand of the upstream activity is increased to ensure the sustainability in the space technology development. We believe this the policy also include the what we call the international collaboration will spur the spirit of the peaceful use of outer space in terms of the regulatory framework, and also we promote the use in terms of to ensure the sustainability of the expertise in our country. So I think the input of the international collaboration is very much important to us right now in term of development of upstream activity in terms of space technology. Thank you.
Thank you. Thank you. Can I go to Mr. Colonel Phillip?
Yes, sir. Thank you. You know, as a country, our challenger is to be able to incorporate the space as a key variable in our national development equation. So if the economy of the country is an engine, we want to allocate a turbo charger. So the idea is to use the space as that kind of turbo, with the proposal to create more value, public value. And the expression of that public value will be in the context of the capacity of the country to improve the quality of life of the people, for one side. On the other side, to promote a digital economy of the country through the space economy. So at the end, it's a matter of development as a country and development as a human being. And the base for that, for sure, will be in the team building capabilities and international collaboration. We are a very open country in the economy, and also we are in the space industry as well.
Thank you. Danny?
Thank you, Mr. Kumar. We have many challenges. When we started to explore space, we had on the list around 30 industries, 30 companies. Now we have 150, together with the startups and universities. And what's of course our future plans are to establish the agency, and of course, as mentioned before, the cooperation is the crucial point, because we are traditionally an export country, and also in space we can not afford to act locally. On the other hand, it is we face some difficulties to attract new companies because, especially in Slovenia, some of them think that space is reserved for big ones, and we would like to step forward and to explain, as Krista already mentioned. Space has unlimited opportunities, and it doesn't matter whether you act in space or on Earth. It's just the matter of how you see business. And yes, this is our future plan, to attract more industry, to attract more actors, and to become a good space player.
Good.
Thank you.
All the best. Hope that you're going to get it soon. Mr. Christoph?
Thank you, Kumar. I now first remember that I avoided your question actually on the space debris and that stuff. And actually, the very short answer to that is that this is also a matter for international regulations. And I think we should give the support to COPUS, for instance, in the United Nations, to see to it that we also get binding regulations to be able to have a sustainable situation in the very attractive nowadays low Earth orbits and so on. We need to be able to have a sustainable amount of satellites. There must be a possibility for the owners to deorbit them in a secure way, to see to that we don't waste this resource that we have. On the challenges, I would say that what we are struggling with in Sweden, that I guess is the same for many space agencies, we're under the Ministry of Education and Research. It is hard to get through and convince politicians that space is actually a cross-sectorial matter that involves all ministries. And if we get a raise, in our budget, is most likely that it's a relocation of money within our research and education budget. So that's one of our endeavors right now, to see to it that convince politicians that space is a national matter that is not only concerning research and so we really need to be able to also get other ministries in Sweden involved in the funding of space activities.
Thank you. Thank you. I think the panel has done the job well. I hope many of the new thought process has started or has to be rolled in, because what a small space-faring nations expect, how the ecosystem would be, how the international cooperations would be, in what areas we can have very wide cooperation, locally to globally. I think I thank again all the panel members sparing their time and sharing their perspective. Probably I think this should open further discussions to have a very global, very healthy and fruitful international cooperations in the space domain, especially in the capacity building. Thank you. Thanks a lot.
Wow, it's a great discussion. Thank you so much, all panelists, for this wonderful insights. Now, I would like to call upon stage Mr. Lakshmesh for closing address and vote of thanks. Mr. Lakshmesh is a mechanical engineer with MBA. He is on the space panel of FICCI, National Space Committee of CII, DNA expert panel for Tamil Nadu, expert panel on AI DAT, and a National Council member of ISSE, Indian Society of Science and Systems Engineering. Sir, I would like to invite on the stage for vote of thanks.
My God. Now, day after day, starting last Sunday, the whole thing has been building up, and today was like the gamma burst with a confluence of great people coming from different continents and different countries across the globe, and with their thoughts on all aspects, creating that huge energy that I think would propel the future of space. So it's been an amazing session. It started off with great thoughts from Mr. Ravindran, who actually put forth, Mr. Dr. Rajivan, who put forth the foundation of the past and also made the proposals for capacities, capabilities, and the research in coming future. Dr. Nilesh Desai then brought about the various aspects of the development and the collaborating effort that is being put forth by him and the entire ISRO organization. And then, of course, came the amazing confluence wherein it was very difficult for me to kind of capture some of the thoughts. So I tried to put those thoughts in a kind of slide that my friend Praneeth helped me to compile it. So I look at this entire session on three major pillars: on the purpose, technology, and collaboration. And when we talk about purpose, the adjective for the purpose is peaceful purpose. And fundamentally, this has to start with global treaties, regulatory mechanisms for making space a boundary-less entity and a common entity. Because we look at space as space for mankind on Earth when you look down from the space. And then there is space for mankind in space. So that's what is the future is. So therefore, the space that we are talking about, whether it is LEO, MEO, or the orbits around the Earth, plays that very vital junction for looking down on Earth and looking outwards. So if we were to look at peaceful purposes, it needs to be on these three further pillars of global regulatory treaties and mechanisms: space for mankind on Earth and space for mankind in space. And now then move on to the second major pillar of technology. First and foremost, because we're talking about human in every of this aspect now. It's not just about satellites and experimental ideas. We are putting human in every part of the space endeavor. And therefore, the reliability becomes the core of all technological innovations and developments. The next very important thing is sustainability, because we are talking about any initiative that needs to have the core foundation of sustainability on Earth. We cannot create a technology that would bring the end closer. We need to build technologies which would push the end of Earth as far away as possible. And therefore, all technological solutions and ideas and ideations have to be sustainable. And end of the day, it has to also be completely affordable. Now, the third big pillar I could understand from the greats who were on the dais today was on collaboration. I could get this thought of a concept called global citizenship. Like each one of us, I'm not an Indian, you're not a Slovenian, you're not a Chilean, we are earthlings. And we have this one single, let's call it as one single village, one single place. And it's actually, as part of our Indian cultural thought, we call it as Vasudeva Kutumbam. That means the whole world is one family. And I think it's the one important concept that we need to bring is that Vasudeva Kutumbam concept of golden citizen attitude. The second and pillar is wherein all the spacefaring nations, the old, the new, and probably the newer ones, need to come together and create that collaborative effort, bring in all those collaborative needs and the solutions to kind of address the whole world as one place. And the third level of collaboration, we could see that there are governments coming together, there are space agencies coming together, there are public agencies coming together, private agencies, academics, startups, private equities. I think it is genuinely a collaboration effort across all kinds of entities, governments to startups. So I think if we were to now look with this kind of a framework and just imagine the entire space as a three-dimensional entity, which it is, on one axis there is old economy, old space and new space. We need to balance between the two. You mentioned about that. On the other one is global united collaborative effort, and on the other end of that axis is individual national economies. I think we need to strike a balance between that. And on the third dimension, the two extremities of the third dimension are, one, we need to make Earth livable for longer, and on the other hand, we need to find places elsewhere. So if I were to look at the entire space as three-dimensional, the extremities of this, I think it is important for all of us to strike that balance between these 6 dimensions or 6 directions. And I think that I capture as the essence of not only this session, today's, but the entire week, which has been an amazing confluence, starting on the first day with all the great people coming together, Dr. Shivan, Dr. Pan Goenka, we had Dr. Uma Maheshwar, Dr. Somnath, we have Dr. Desai today from ISRO. Dr. Sudhir Kumar has been the very foundation. He's the one who has completely planned this throughout the session. Thank you very much, sir, for that amazing confluence that you've been able to bring together. Thanks to all the FICI team who have been, I don't see Vivek Pandit here. His dad's not well, so I think he had to get back. Then we have Chirag, Amar, Geetika, and the entire team. What a wonderful job you guys have done. Thank you very much. And of course, I must really thank all those boys and girls who have been kind of at our stalls, working backstage here. Great hand to, thanks to you all. Thank you very much. And we must thank the Deaf Expo, which made all this happen. That we all came together here from all our various countries, various locations. So thank you very much for making this Space Week a great time for all of us. So once again, thanking you all and praying and hoping that all of us would make this space a common growth area for all of us. Thank you very much. I'm sorry if I would have missed out mentioning some of people and some of the agencies, but from heart, thanks to everyone.
Thank you so much, Lakshmi sir. Now with this, we have reached to the end of the seminar. It's been a wonderful week for all of us. We have got some great opportunity to meet some great speakers. I'm sure this will help us to extend our mutual cooperation across nations and discover new avenues of business and collaborations. With this, I would like to thank all of you, all the speakers, panelists, delegates, audiences for joining us today. Thank you so much, and have a great day ahead. Thank you.